Good day and welcome to One-on-One Maths Private Tutors. Today we are looking at O-Level and IGCSE Pure Physics. The topic is Center of Gravity and Stability. Center of gravity. An object behaves as if its whole mass were concentrated at one point, called its center of gravity. Even though the Earth attracts every part of it, the object's weight can be considered to act at this point. The center of gravity of a uniform ruler is at its center, and when supported there, it can be balanced. So we can see in this diagram, if you put a pivot at the center of a ruler, it will balance at that point. So the center of gravity is at the center of that uniform ruler. Any other point topples it because the moment of its weight about the point of support is not zero. So if you put a pivot there, it will have a clockwise moment. If you put a pivot there, it will have an anti-clockwise moment due to the weight at the center. The center of gravity is sometimes also called the center of mass. For a definition, the center of gravity is the point through which all of an object's weight can be considered to act. Your center of gravity is near the center of your body, close to the belly button, and the vertical line from it to the floor must be within the area enclosed by your feet, or you will fall over. You can test this by standing with one arm and the side of one foot pressed against the wall. Now, if you try to raise the other leg, this other leg, sideways, you will fall over. So the center of mass is somewhere here. So this will create a pivot there and will cause you to topple. A tightrope walker has to keep their center of gravity exactly above the rope. Some carry a long pole to help them balance. The combined weight of the walker and the pole is then spread out more, and if the walker begins to topple to one side, they move the pole to the other side. The center of gravity of a regularly shaped object that has the same density throughout is at its center. In other cases, it can be found by experiment. Let's look at this experiment on the center of gravity of an irregularly shaped lamina. So an irregularly shaped lamina is like a piece of cardboard that has an irregular shape. It is almost plain with the same thickness throughout. Suppose we have to find the center of gravity of an irregularly shaped lamina or a thin sheet of cardboard. First, we make a hole A in the lamina and hang it so that it can swing freely on a nail clamped to a stand. So we'll make a hole there, A, and put a nail or a pin so that it swings freely. It will come to rest with its center of gravity vertically below this hole A. To locate the vertical line through A, tie a plumb line. A plumb line is a thread and a weight. So we tie the plumb line to the nail. So we'll put a string there, tie it to the nail, let it hang loose with a weight there or a bob. So this string and a bob or a weight is what we call a plumb line. And mark its position, AB, on the lamina. So we want to mark a position there. This is AB from the hole along the plumb line. The center of gravity lies somewhere between AB. So the center of gravity is somewhere there. Hang the lamina from another position C. So now we choose another position, let's say here, C. Then we make a hole at C and mark the plumb line position CD. So again, we put a nail through C and then put our plumb line there. Remember, we had our A, B like that. Now we put another position C and hang our lamina freely. When it comes to a stop, we put a plumb line, then mark the position C, D. Now, where these two lines A, B, and C, D meet, that's the center of gravity. The center of gravity lies on CD and must be at the point of intersection of AB and CD. Check this by hanging the lamina from a third hole. So if you choose a third hole there, let's call it E, then we hang our lamina on a nail through E. We will find that our A, B, C, D, and now E, E, if we hang a plumb line there through E, it will also pass through this point of intersection. EF will pass through this point of intersection of AB and CD. So our center of gravity will be consistent. So this is the experiment. First, we need a retort stand and the irregularly shaped lamina. So we make 3 holes, P, Q, and R, near the edge of the lamina, so that the lamina can swing freely when pivoted from each hole. We suspend the lamina first from the point P as shown. We hang a plumb line from the point P and mark the plumbing line when the plumb line is rested. So we mark on the lamina, then draw a line from P to the point we have marked. Then we suspend the lamina from the other hole, Q, and put the plumb line. And when it comes to rest, we mark the point along the plumb line. Then we connect the line from Q to the point we have marked there. We do the same procedure for the point R. When the plumb line comes to rest, we mark a point on the lamina, then connect all the 3 lines meet at a point, and that point is the center of gravity. If we pivot the lamina at that point, it will balance. So that is how we find the center of gravity of a plane irregular lamina. Now we move to stability. The position of the center of gravity of an object affects whether or not it will be stable when tilted. This is important in the design of such things as tall vehicles like double-decker buses, which tend to overturn when rounding a corner. It is also important in designing racing cars, reading lamps, and even drinking glasses. An object topples or falls over when the vertical line through its center of gravity falls outside its base. So we can see on this diagram, the center of gravity is here and the base is there. So this will topple over. But on B, the center of gravity is between the base edges, so it will come back and will be stable. This diagram shows a toppling object. This diagram shows a stable object that will not topple. Toppling can be investigated by placing an empty can on a plank with a rough surface to prevent slipping, which is slowly tilted. The angle of tilt is noted when the can falls over. This is repeated with a mass of 1 kg in the can, and we observe how it affects the position of the center of gravity. The same procedure is followed with a second can of the same height as the first, but with a greater base width. It will then be found that the second can with the mass in it can be tilted through a greater angle. The stability of a body is therefore increased by 1, lowering its center of gravity. So an object like this and an object like that, if the center of gravity is there and the center of gravity here is there, this center of gravity is lower than that center of gravity. So this is more stable. This is less stable because it takes a lesser angle for this center of gravity to go beyond the base when we tilt it that way. As opposed to here, we need a larger angle of tilt for this center of gravity to go beyond this edge. Stability of the body is also increased by increasing the area of the base. In this diagram, the center of gravity of a fire truck is being found. It is necessary to do this when testing a new design, since fire trucks are often driven over sloping surfaces, and any tendency to overturn must be discovered. In this diagram, the stability of a coach or a bus is being tested when the top deck only is fully loaded with passengers. It must not topple if tilted through an angle of 28 degrees. Racing cars have a low center of gravity and a wide wheelbase for maximum stability. Now let's look at the questions that typically come in the exam. A car is designed to be stable. To achieve good stability, where is the center of mass of the car? The center of mass of the car must be as low as possible. So above the front wheels is wrong, above the rear wheels is wrong, as high in the car as possible, wrong, as low in the car as possible. So our answer is D. A man uses clay to make a pot. He wants the pot to be as stable as possible when placed on a flat surface. Which two features of the pot must the man consider? The area of the base and the height of the center of gravity. This looks like an answer. The density of the clay. No, we should not consider the density. The only two things we'll consider are the center of gravity and area of the base. The density, no, we don't consider density or weight. So our answer is A. The area of the base, as we have seen here, area of the base and center of gravity are two things to consider for stability. So our answer is A. When a car turns a corner at a speed, it risks toppling over. Two factors affecting the stability of a car are the height of its center of mass and the distance between the front wheels. Which factors makes the car most stable? Center of mass must be low and the distance between the wheels must be large. So D is our answer. 4 table lamps are shown along with the position M of its center of mass in each case. Which lamp is the most stable? So we want one with a wider base. This one is the widest base and the lowest center of gravity. So A is our answer. Was it as the widest base and the lowest center of gravity? A car is designed to be stable. Where must the center of gravity of the car be? It should be as low as possible, as low in the car as possible, which makes our answer D. Thank you.